NASA's moon base is taking shape. 20 EY lunar landings could build the foundation. Imagine looking at the moon and seeing something that has never existed there before. Not just a spacecraft or a temporary astronaut mission, but the beginnings of a permanent human foothold. NASA is now moving toward that vision with an ambitious series of robotic missions designed to build the infrastructure, test the technology, and gather the knowledge needed for a sustained presence near the moon's south pole. According to NASA's latest update, more than 20 robotic lunar landings are planned through 2029, with missions involving commercial landers, scientific instruments, rovers, communication systems, power technologies, and experiments designed to survive the moon's brutal environment. This is not a moon base appearing overnight. Instead, NASA is taking a step-by-step approach in which robots arrive first, test the environment, deliver equipment, and gradually establish the capabilities that future astronauts could depend on. The strategy represents a major shift toward using commercial companies as part of America's lunar transportation network. NASA is working with companies including Blue Origin, Firefly Aerospace, Intuitive Machines, and Voyager Lunar Systems, whose landers are being prepared to deliver equipment and scientific payloads to the lunar surface. The idea is straightforward. Instead of NASA developing and operating every lunar lander itself, commercial spacecraft can provide repeated cargo deliveries while NASA concentrates on the scientific and technological objectives of the broader lunar program. NASA's Phase I architecture, currently running through 2029, calls for more than 20 robotic landings. Each mission is intended to build on what came before, testing capabilities and delivering new equipment while giving engineers valuable experience operating on the moon. The Commercial Lunar Payload Services Program, or CLPs, is expected to help create a more reliable lunar supply chain, something that could become essential if humans eventually begin spending extended periods on the lunar surface. One of the most important missions comes from Blue Origin, whose Blue Moon Macone lander is progressing through testing ahead of its planned lunar delivery mission called Endurance. The spacecraft has already completed major environmental testing, including a thermal vacuum assessment at NASA's Johnson Space Center designed to simulate the harsh conditions it could encounter on the moon. Its structure, propulsion systems, and avionics have been assembled, while additional integration work and communications testing continue. The lander has also completed communications checks involving NASA's tracking and deep space communication infrastructure. Endurance is expected to demonstrate precision landing, study the lunar environment, and test autonomous systems that could eventually become important components of future moonbase operations. These may sound like incremental engineering milestones, but on the moon, reliable landing and autonomous operation are fundamental requirements. A spacecraft carrying critical equipment hundreds of thousands of kilometers from Earth cannot simply depend on engineers manually controlling every moment of its mission. Firefly Aerospace is taking the lunar exploration effort in another direction with Blue Ghost Mission 2, a larger configuration designed for operations on the moon's far side. The spacecraft will be combined with Firefly's Elytra orbital vehicle, creating a system approximately 22 feet tall. Unlike a simple lander, this architecture can provide greater flexibility by deploying payloads both from lunar orbit and onto the surface. If the mission proceeds as planned, Blue Ghost Mission 2 could become the first American landing on the far side of the moon. That region is scientifically fascinating because it provides access to geology that differs from the familiar near side and offers an unusually radio-quiet environment for investigating the universe's early history, including the cosmic dark ages. 3 NASA payloads are planned for the mission, combining scientific investigation with technology demonstrations that could contribute to future lunar infrastructure. Firefly is also building on experience from its first Blue Ghost mission, reusing some proven subsystems to reduce development risk and accelerate future lunar operations. Then there is Intuitive Machines preparing its third Nova C lunar landing mission, IM-3, using a lander named Trinity. This mission is especially interesting because it will also introduce Altus 1, the company's first lunar data relay satellite. Trinity is expected to carry 5 NASA payloads, 6 commercial payloads, and 1 civil payload to the lunar surface, while Altus 1 will be deployed into lunar orbit. The mission is designed not simply to deliver equipment, but to investigate one of the moon's strangest features, Reiner Gamma, a lunar swirl associated with unusual magnetic conditions. If successful, IM-3 is expected to become the first mission to explore the surface of a lunar swirl directly, allowing instruments and robotic systems to investigate a region whose origin and properties remain poorly understood. At the same time, extensive thermal vacuum testing and other engineering evaluations are being performed to make sure the spacecraft systems can survive the extreme temperature changes associated with lunar operations. Another major piece of the puzzle is Voyager Technologies' Griffin 1 lander, an infrastructure-class spacecraft scheduled for launch in late 2026. NASA's testing campaign at the Jet Propulsion Laboratory is designed to determine whether the lander can withstand the stresses of launch, the journey to the moon, and the demanding conditions of lunar landing and surface operations. Griffin 1 is expected to carry what NASA describes as the largest commercial payload ever delivered to the lunar surface. Among its payloads will be NASA instruments mounted on Astrolab's Flex Lunar Innovation Platform, or FLIP, a rover designed to improve lunar mobility and demonstrate technologies that could eventually support longer duration operations. Griffin 1 has already completed mass properties testing, which provides crucial information for guidance, navigation, control, and flight dynamics. Additional environmental testing will attempt to reproduce the conditions the spacecraft will experience from launch through landing before it moves toward final assembly and launch preparations. But landing spacecraft is only one part of establishing a sustainable lunar presence. NASA is also testing technologies that will have to survive the moon's extreme environment, particularly the lunar night. The agency is working with Northrop Grumman on 3 technology demonstrations that use power and avionics hardware originally developed for the Gateway program's Halo module. The hardware is being adapted for surface operations, reflecting NASA's increasing emphasis on infrastructure directly on the moon. Some of the demonstrations will test systems capable of surviving periods of darkness lasting multiple days, while others will examine shared surface power infrastructure capable of supplying electricity to payloads and future moon base assets. These experiments address one of the most fundamental challenges of lunar habitation, keeping critical equipment alive when the environment becomes brutally cold and sunlight disappears. And that is why the most important part of NASA's moon-based plan may not be any single lander. It is the network of capabilities being assembled piece by piece. Reliable cargo transportation, precision landing, autonomous navigation, lunar communications, surface mobility, power generation, environmental survival, scientific investigation, and eventually human support systems all have to work together. The first robotic missions provide NASA with something that simulations alone cannot provide: real experience operating hardware on the lunar surface. Every successful landing can reveal something new, while every failure can expose a problem before astronauts depend on the same technology. The larger vision is therefore much bigger than simply sending more spacecraft to the moon. NASA is attempting to establish the foundations of a lasting robotic and human presence near the lunar South Pole. The coming years could see a steady stream of commercial landers delivering instruments, experiments, rovers, communications equipment, power systems, and other technologies. Some missions will explore scientifically unusual regions. Others will test technologies that may seem mundane, but could become essential to future lunar settlements. And together, these missions could gradually transform the moon from a destination visited occasionally into a place where infrastructure is continuously operating. NASA's current plan is still developing, and the missions described here remain subject to the challenges inherent in lunar exploration. But if the planned sequence succeeds, the moon may soon begin to look less like a place humanity visits, and more like a place where humanity is beginning to build. The moon base may not begin with astronauts building habitats. It may begin with robots quietly delivering the pieces that make those habitats possible. And over the next few years, more than 20 lunar landings could determine whether that vision becomes reality.